So this containerization, this container deployment helps us to uh, take up a new kind of deployment called as a microservices. So we can split a system into microservice containers. So that is a microservice containers. So for example, if you take a microservice container, you can have a different Docker files written. The application would be one, but you can write a different Docker files for each service which is working in the same application, in the same app, and all can be all can be built as different Docker images, and all can be run as different containers, and each container can be connected or orchestrated through either Docker Compose or Kubernetes. So example here, database Docker file, app Docker file, web Docker file, and you can use npm Docker file, and all can be connected through Docker Compose or a Kubernetes, whichever orchestration tool you want to go with. So now we are going to do an example on and an exercise which is specific to microservices. So we will be working on Emart app microservices. So this consists of so we will do this Emart app microservice deployment using Docker Compose. So it consists of a different services and which belongs to single application. A single application can be made into microservices, and you can run different containers for each microservice, and we can run our application. So let's look into that now. Emart microservices project. So hello and welcome to the Emart microservices project, an exciting and very recent development project. So this is recently uh, most of the companies are going for microservices. Even Google, they deploy lakhs of containers every day, part of their microservices project. So we will look into this microservice project. So in this session, we will talk about how we containerize a microservice application, and what is microservice and how it is very good in software development and delivering features to users very quickly and efficiently. If we start talking about its advantages, there are many, but the point is microservice architecture is here, and we're going to stay for and the microservices architecture is here, and it's gonna stay here in this world for very long time. So it's not a fad. The fad, uh some technology and tools are fad, they come and go, but this one, our microservice, is not a fad. It will stay for a long time. And being a DevOps and MLOps guy, I and you should definitely witness microservice application, and you should know first how to containerize it. So this slide is for that. So discuss about this. Uh, we will discuss completely about that Emart application first, and then we will go for the containerization. So this Emart application consists of the following services. That is, the first one is Nginx. Nginx will be used as API gateway here in this case. And Angular is a client-side service, and Node.js is Emart app, and Java is a books app, and MongoDB database as a database for Node.js. And setup should, and MySQL is one more database. It is SQL database for books application. So now the number of services are clear. Now we will see setup, how to do the setup. So setup should be done in below mentioned order. We will begin with MySQL, that is the database service, MongoDB database caching service, and Angular, that is our client. Node.js is Emart app, and Java is our books app, and Nginx is our API gateway. So now let's see the flow. Flow of WIP, flow of Emart. Now let's look into the flow of Emart microservices web application. We will look into the web architecture. So let's go to it once again. So we have total 1, 2, 3, 4, and here 1, 2, 3, 4, and it's total these many services we have here. So we'll begin with Nginx. So Nginx, which is the API gateway, which is the front end from where all the requests comes, and all the communication between microservices happen through API gateway. So this will be an Nginx service which will listen for the request and route based on the headers, based on the URLs. So if the request comes on a route, that is, if you are just accessing the URL, then it sends to the client microservice which is written in Angular. That is here, AngularJS, the client microservice. That's in Angular. That's just a route. If route is just a forward slash, then it will go to the Angular JS service, and there the client will be the client end side will be served. If it is forward slash API, and it will go to the Emart API using Node.js service. If it is forward slash web API, then it will be routed to the books API, which is based on Java service. And so this loads the front end pages of the website. If it just goes using forward slash routing, if it is routed through forward slash only, then it goes to the client through AngularJS service. Then it loads the front end pages of the website, and for the backend data, it's going to contact the API service Emart API service Emart API. So that is forward slash API route. So which is written in Node.js, and the URL will be API. That's forward slash API and Node.js application. So these APIs will need a database. This Node Emart API, this application requires a database, and here we are using MongoDB and NoSQL database, or MongoDB is a NoSQL database. MongoDB is a NoSQL database, and MySQL is a SQL database. So next, there is also one more integration of another service, Books API, and this is written in Java. And it uses MySQL database, which is an SQL database, and its URL is forward slash web API. So this is an e-commerce application which has a multiple microservices. However, Nginx is the important aspect here. It's a gateway. When it gets a route of forward slash, it will be routed to client side, and the front end pages will be shown, and AngularJS will serve this. Whereas if it is requested for the forward slash API, then it will be routed to Emart API, and it will be served by Node.js. And if it is is requested through forward slash web API, it will be routed to books API, and Java will be serving this. Whereas for Emart API and Java, that's books API, it requires a database to continue dynamically work and to store. So that's the reason we use a MongoDB, a NoSQL database for Emart API, whereas for books API, relational database is absolutely fine. So that is the reason we have gone with MySQL. So as usual, we will work on this microservice Emart app. So for that, we will note down the steps that to be followed. So it's as similar to that, but slight changes that we can see here. So let me add V Pro. So here in this case, it's Emart microservices project. Emart microservices project. So as usual, step 1 remains same, and step 2 it changes from step 2. So let me copy these things and paste it here. So for me, no step 2 here in this case. Step 1, create AWS EC2 instance and install git docker compose. It's been done. Then fetch the source code of the application and create an organization. Okay. So this one is not required in this case. We are not going to do because we don't want to repeat the same step again and again. So this is also not there. So here, let me rewrite all the steps. So step 2 is to create a repository in GitHub and push the source code to git repo. Git repo. Then step 3, clone git repo into EC2 instance or our server. Then step 4, write Docker files for each service, customize it. Then step 5, build Docker images. And step 6, write Docker compose file. And step 7, time to do Docker compose up. And step 8 is validation. Let's do that. First step is done, and now second step, let's create a repository in our GitHub account. So this is my GitHub account. Let me click on your repositories and create a new repository. So here I am gonna say Docker micro Emart app. That would be better. Emart app. And so let me create a public repository with a readme.md markdown file. And let me create a Visual Studio Code. Let me open a Visual Studio Code and run as administrator and S. So absolutely it had opened a new file. So clone git repository. So remote repos. So Emart. So Docker Emart. This is what we want. And let me select a destination directory. So that's an Emart containerizing, or simply let me get into the D and Imlike projects, and it's v Emart main. That's it. So let me add all the files to our repository and replace the file destination. and client is also should be added. Just a minute. Yeah, it's all done. So now let us get into our VS Code, and you see that all our files are ready 140. So let me add these files to the staging area. Yes, yes, all has been added. Now committing source code and click commit and wait for action to happen. That's it. Sync changes, and once it is done, let's get into our GitHub account and we will cross check whether all has been pushed or not. Let me check here. Yes, it is. Yes, it's ready. So client, Java API, K-card chart, Nginx, Node API, everything is ready. So the two steps has been successfully completed. Those are create a repository in GitHub and push the source code to Git a repo. Now let's clone a Git repo into EC2 instance. So let me copy this and get into my EC2 instance or Docker server. Sudo option I and clear the screen and mkdir home Ubuntu, and here I'm gonna create Emart app. So cd home Ubuntu Emart and ls, nothing is there. So here I'm gonna clone git clone and so the repository, the source code has been cloned. Now let me do ls. So cd docker emart ls. So this is what it consists of. Let me give ls lrt. So before that, let's go through this directory once. I'm gonna open it. So here we have explorer and how many. So let me also, so PowerPoint slide here. Yeah, so we have Nginx, Angular, Node.js, Java, Mongo, MySQL. Okay, so let's get into that. So client, Java API, KKR chart, Nginx, Node API. So let me look into the client. So client, as we have discussed earlier, so client consists of a Docker Emart, and inside that you can see the source files, so E to E, so all the information about the client. Then we have Java API, and we have charts, Nginx. This is Nginx and this is default config file, and this is how a default config file looks like. And this is API gateway. API gateway also consists of one config file. So upstream books API. So this is upstream books API, and then we have given that, and then upstream client and listen 880. That's the actual one. And then you see for each route, so /API and then /web API and just a / for each route it's been defined. That's what our config file. And we have Node API. So Node API consists of all So Node API is the main API file, and it's the main application. So it consists of Emart application. So that's the reason it has all information, key.js, images that is used in that, and models, and routes. So routes, you can see the routes here, and validation. So all the information. So this is what is our application. So let me save this. So now let us look into the next step. So cloning has been done. So now let's look into the Docker files for required service. So let's get into our instance. So clear the screen. So we will do ls, and we will begin with the client. So cd client ls, and so this consists of following files: angular.json. This is what the client client side script. The client side script is angular.json, and nginx conf file is also there, and here you will find the source code, complete source code, and here you have package.json. So let me do the cat package.json, and the complete information about the package.json. So let me do ls. Yep, let me go one step back, but before that, let's look into the Docker file that's present. Docker file that is required to be written for the client, that is angular.json. That's Angular service. So let's write that vim. Yes. So it's begin with, as usual, a base image, that is node 14 as web build. So we are mentioning as a web build. The name we have given is a given it to as web build. Then work there is this user source app, and copy the present working directory of this of the place where our Docker file is presented to the forward slash client. Then run the following commands: cd to the client, then npm install and npm run build option prod. So in addition to that, we are doing this a multi-image. We are doing it as a multi-stage image. So here we are going to build one more image called nginx latest, and copy the build output to replace the default nginx contents from here. So, and finally we are exposing it to the port 4200. So let me save and quit it, and let me get back to the higher level directory. And here now let's see into the Java API. So cd Java API. So here we can see, here also we'll write our Docker file. Here we'll have a Docker script, basically JavaScript, and this is a books API. So here again, here we have used OpenJDK and version 8 as a build image, and work there is this, and we want to update the package, and then we want to install it inside that, so that we can create a package, we can create an artifact. Once the artifact is ready, then you can put it in a required directory, then you can run it. Java jar book work this. So whenever is required, so when you call when you click on that client user interface, so this one will be so it will be routed to Java books API application. For now, let me close and save it. So now let's get back and do ls, and look into the node API, the very most important API. So ls, and do vim docker file. So vim, again, this node API. So this is also taking up a same node 14 image, and work there, and rest all remains same, but the command is bin shell because it's a node. There won't be any bash sh is using, and option c and cd user src app and npm start. We are starting the container. When we start the container, That's what is going to happen. So now in addition to that, you have config images models package log.json package.json, and here you will find routes and server.json. All the things are present in this. So let's get back to the one stage, and then let's look into the nginx cd nginx and ls. Here in nginx you will see the API gateway. So in this API gateway we will find out the default .config file. So let me do cat default config, and here you will see complete information about routes. See how you can, how that routes it, location forward slash API. With this route it will take to this, and with location forward slash web API it will go to the books API. In this one goes to the Emart API. So that's how we use it. And here if it is just a forward slash and in WebSockets, and it will take to the client. Okay, we have seen this also. Now let's get back and let's look into the KKR chart. And here you can find out different chart.ml templates and all those things. Let me get back to the main directory, and it's called project directory. Let me clear it. Now we have written our Docker files. So this step also has been done. So our Docker file is absolutely ready. So now instead of building Docker images and giving the Docker images tags or names, what I'm going to do is I'm directly write a Docker compose file. Inside the Docker compose file, I'm going to mention the name of the Docker file or the location path of the Docker file, so that it can itself build the Docker image. So let's do that. So let me write vim docker file, no, vim docker compose.ml, and this is our docker compose ml. We'll begin with, so version 1 3.8, and we have services here. Client is one service which is based on an API and web API and nginx and emongo and emartdb. So total we have around 6, and these are the identifiers of each service. The first service is client, and that is node.js. And so build context is the path where we'll find a docker file. So it is in client directory, and port mapping is 4200 to port 4200, and container name we are going to give is a client, and depends on this uh, routes. Then second one is API. So again this docker file is in node API, and then port mapping is 5000 to 5000, and container name is API, this one. And then depends on nginx and depends on emongo. So this API is going to, this container is going to use emongo as a backend database, and it also depends upon nginx to get routed. So then we have web API, it's Java API, or you can also say books API. It's written in Java, and the Docker file is in it's in Java API directory. Just now we have created these things. Then port mapping is 9000 to 9000, and restart always. Container name is web API, and it always depends on emartdb. So emartdb is MySQL. Then we have nginx. So nginx image, nginx latest version we are taking. Container name is nginx volumes. So here we are volume mounting. It's basically you can clearly see this is a bind mount, and then ports 880 is mapped with 80, and command nginx debug, that is our command, and then option G and daemon off. So depends on client. Nginx is depends upon client. Okay, because the first landing takes place on the client, and after that nginx comes into the picture. So that's the reason nginx is depends upon client, and rest all will be depends upon nginx, whereas one more service also depends upon client. And finally we have emongo and emartdb. These are databases. Here we are going to pull the images directly, that is emongo. Image is mongo and version 4, and container name we want to get it as a emongo, and environment we have given the mongo init db database, so initialization of database, and with name epoch, and port number is 27017 is mapped from host machine to container. Then we have final one emart db, so image name is mysql and version is 5.7, that's a tag, and container name is emart.db, and ports are 3306 mapped with 3306. This is by default for the MySQL. And environment variable we have used is MySQL root password, that is emart.db pass, and then MySQL database, that's books. So with this we have successfully written our Docker compose file. So what left for us is to run Docker compose up. Docker compose up option D. So emartdb and emongodb are being pulled. So these are the names of the containers are mentioned here. That's what we have given. So no space left on device. So just give me some time. I'm going to clean up all the images, all the existing images, and then we will rerun it. So Docker images. Oh, we have huge amount of images. There is no space. Let me clean it. Let me clean it. Okay. So Docker rmi. So let me begin with I do not. Okay, let me clean up everything so it can pull again. So MySQL 5 and OpenJDK 8, Node Alpine and CubeCharan Node Debian. Yeah, done. And Nginx latest, Memcached latest, Redis Redis Alpine, and CubeCharan Redis Alpine, Ubuntu latest, CubeCharan Ubuntu, and Tomcat, MySQL 8, and RabbitMQ latest, and CubeCharan server, and CubeCharan client, and Flask, CubeCharan Flask web, and schedule list and version 1, and cube schedule list tag name, and just schedule list, and vprofile charan vipro app version 1, and vprofile vipro app version 1. So let me delete all these images. Let me clean it up completely. So now Docker images. That's it. Only 3 are left. So let me do Docker RMI vprofile vipro app version v1, and let me delete that, and Docker images. Few more are left. Let me delete these things also. Docker RMI vprofile vipro web vprofile vipro db version 1, and I will give the image IDs for remaining things that's which are not tagged. So copy paste it, and copy space and paste it. So let me cross check. I think all should have been deleted. Docker images. So done. So docker ps option a. Yeah, all clear, all done. Let's do docker compose up and with detached mode. So Emart DB, emongo, nginx all have been pulling. So all have been being pulled to our machine, because there we have just mentioned the official image names. So then nginx is also being pulled, and after that for a remaining we are going to build through Dockerfile. You can see that it's building from Dockerfile. Before it was pulling, now it is building from Dockerfile, and the Docker images have been built, that we can see. So you have to observe the color coding also, and each layer that we have mentioned inside that. Now Emart web API. So each layer is being built. So work there for Docker Emart web API build image. So work there user src app. That's what we have given. Now the Maven is being installed, and once installation of Maven is done, then it's going to build a package. So all those things have been copied here. You can see that. So it's gonna take a few more minutes. So package I think has been built. So it's exporting the layers. So now it's getting built, I think. So installation of Maven, at this process the action is taking place. So now a package run mvn install dskip test. So we just want to skip the tests, and we want to create an artifact. So now artifact is going to be created. So that's what is happening there. Let's wait for a few more minutes. So that's it. Network, Emart app default created and container, emongo, Emart DB, Web API, Client, Nginx, all has been started. So our network has been created and all other containers has been started. So let's look into the Docker images first. So you see that we have all the images here. So Emart Web API, Emart Client, Emart API, Mongo, MySQL, Nginx, all images are created. And let's look into the Docker PS, that's containers. You can see the all the containers: Nginx, Client API, Web API, emongo, Emart DB. For us, we have to access Nginx because it is our API gateway. As this is API gateway, we are going to access Nginx. For that, let me get into our instance, public IP, and copy this here and paste it here. That's it. Successful. We are able to access a microservices application successfully. So sign in, admin, and password. Email is not valid, so we have to create. Okay, we have to register first. Never. So anything random, admin, and admin. So let me click next. One, first name, content, 32432. So register. So never, I think. Could not register. Okay. And once you log into this, you should able to see your Emart app and other books API and everything. Okay, so here I am unable to create an account. That's okay. So we can do that, but we are able to access this application successfully. Here you can see all the containers which are up and running. So this is our API gateway, and then Emart app client, and then Emart app API, then web API, and Mongo and MySQL. These are all our databases, and all are up and running successfully. So let's get into our sticky note, and we have used Docker Compose up and successfully run that, and validation is also done it. So let's get back to this. So with this, the microservices web architecture application also has been deployed successfully with Docker Compose.